on page 334. All right. So what I've done so far is just sketched a picture of the sine function. Okay. So thinking back to the unit circle, you know, I'm always thinking, is it the sine that looks like this or the cosine? I always think of the fact that the sine at 0 is 0. So that's the one that goes through 0, 0. So, you know, when we think about the unit circle, then I'm just drawing a quick graph of that. Okay. For the sine function, again, this one is just the regular sine function. Okay. The domain is all real numbers because it goes left and right forever. And the range is from -1 to 1. But now they're going to talk in this section about the inverse sine function. Again, what happens when you invert this thing? Okay. If I was to try to draw that, I warn you, it won't be a very good drawing. But again, what would happen is we'd get this kind of thing. Notice I'm drawing it lightly because it's not going to really end up being all of that. All right? Because what happens is if my inverse of the sine looks like this, it's not a function, which we might not see as a problem, you know, so what? We have other stuff that's not a function. But in order for our calculator to give us answers, it has to be restricted. Okay? And so our book goes through all of those things again. You know, it wants it to be continuous. It wants the domain to include from 0 to pi over 2, reading at the top of page 335. Okay? And the function should take on all values of the range. So again, we want it to include -1 to 1. We want it to include from 0 to pi over 2. And we want it to be continuous. Okay? So what happens is the part that they end up using is this part right here. This is the restricted part. Okay. So that's the restricted part, the part that they use. Again, it is continuous. Okay? Does include the values from 0 to pi over 2, which again are important when we solve right triangle problems. Okay? And it takes on all the values of the range from -1 to 1. Now when we graph the inverse sine, then sometimes called the arc sine, right? Don't let that other name confuse you. We know that when we graph inverses, we switch x and y. Okay? So before, for the sine function, all of my multiples of pi and pi over 2 and all of that were on the x-axis. Now they're going to be on the y-axis. So we'll call this pi over 2 and this pi. This would be -pi over 2 and -pi. And these were just ones, all right? So we'll put +1 over here and -1 over here. All right. Well, this function doesn't even seem to change a lot when you invert it because 0, 0 would stay 0, 0, right? This is -pi over 2, -1. -pi over 2, -1. So it'd be -1, -pi over 2. This one is pi over 2, 1. So it's going to become 1 pi over 2. And then again, if we graph some points in between, it would bend like this. So now the inverse sine, or the arc sine, has a domain only from -1 is less than or equal to x is less than or equal to 1. Or again, remember that if you like the set notation, you can use it this way, the interval notation. The range, again, before that was the range up here. The range is from -pi over 2 is less than or equal to y is less than or equal to pi over 2. Or -pi over 2 with a bracket to pi over 2. Okay. And again, that's what that limiting process is what allows your calculator to find one answer instead of millions of answers. Okay? So it says, I'm going to find you one answer in this area, and then, you know, if you have to worry about other answers, well, you'll just have to do that part. Okay? So that's what they talk about on page 334 and 335. Then we have answers or examples like this, where it wants us to find the inverse sine of a half. Okay, stuff like that. And if it doesn't tell you your mode, you can pick it. But if it does, you'll want to follow that. Okay. Let's say we want to find this in degrees. Remember that whole inverse thing, that's what it does. It finds you an angle. All right. Be able to tell me what the inverse sine of a half is in degrees. Did you get 30? All right, 30 degrees. Again, remember if it asks you arc sine, that's the same thing. Arc sine of negative 0.833. Okay. That one's not going to be exact. Let's do this one in radians. Be able to tell me what that answer is, please. What did you end up with? Negative 0.985, somewhere in there. Okay. All right, and then of course using inverse sine to solve problems like we already have. We've used setup problems with sine, and we've used inverse sine to solve those problems. We've solved triangle problems with those. Okay. Just a reminder about number 5, because that's a big old table problem. Okay. And just want to make sure you understand what's going on. You saw this before with the cosine. Okay. Just a reminder, you're just plugging angles in and getting the y coordinates. Make sure you're in radian mode. Okay. What goes on in this second row again? You just trade them, you're just flipping them. X becomes Y, okay? That sort of thing. So for tomorrow, chapter 5, assignment 5.